Welcome to Luca and Miguel. Enjoy the video.
You begin by preparing the 300 mm wafer and EUV mask. Cleanliness matters because contaminants ruin 5 nm features. Once done, spin a high-resolution resist and prebake to remove solvents, then set the exposure dose precisely for small critical dimensions. Make sure to align the mask to the wafer with sub-nanometer overlay controls. This alignment is the foundation for every subsequent layer. These first steps establish the pattern fidelity you will preserve through deposition, etch, and inspection. You now expose the pattern with EUV and develop the resist while monitoring critical dimensions. This is where stochastic effects appear, so verify uniformity across die. Next, deposit films using ALD or CVD to achieve angstrom-level thickness control. Accurate film stacks define transistor gates and interconnects. Once films are in place, perform anisotropic and atomic layer etch to create vertical profiles and avoid footing. Make sure to loop metrology after each step, so you catch drift before it multiplies across layers. You finish by planarizing layers with CMP and using metrology to verify topography. If deviations exceed a few nanometers, correct with targeted rework because uneven surfaces break lithography at 5 nm. Then fill vias and form metal interconnects and run electrical wafer tests to screen defects. Once tested, dice, bond, and package the chips, then run final burn-in and yield analysis to validate performance. Troubleshooting tip: if yield is low, isolate via-level defects with TEM and loop back to deposition.
Thanks for watching and please subscribe. It's the best investment you'll ever make.